Well, hey everyone, Jason here at Alorium Technology. Happy CircuitPython Day 2020. That's right, today is September 9th, 2020, the day scheduled and set aside by Adafruit Industries, the creators of CircuitPython, as CircuitPython Day 2020. So today is the day where we celebrate all cool things CircuitPython. There's lots of live streams and events and tutorial stuff being scheduled for today, just kind of showing off and talking about CircuitPython, get it more visibility and introduce people to it and hopefully generate some additional interest. Well, it just so happens our latest board, the Evo M51 board, also supports CircuitPython, was designed to do so from the very beginning. And since we support CircuitPython, I really wanted to do a video on this day to let everybody know about it and continue to hopefully build some awareness about this cool programming language and all the neat things you can do with it. And what we're going to do is kind of just jump into how you put our CircuitPython on our board. And let's go ahead and get started. So once again, the board we're going to be using for this video is our Evo M51 board. Now this is a relatively new board. We've had this in production for only a couple of months, and it has two chips on it. So instead of just a single FPGA like we have in our other hardware, we have two. We have the Intel Max 10 FPGA. Again, that's what we've used with our other hardware as well. But this time, instead of having an embedded microcontroller, we've got the SAMD51, make sure I enunciate well, microcontroller that is an Atmel part. It's got a Cortex M4 32-bit microcontroller in that chip. Very, very capable microcontroller. So putting that next to the Intel Max 10 FPGA provides a whole lot of horsepower and capability and things you can do with it. Now, this board that I'm holding right here is actually just a mechanical sample that we have. So this is not the one that I'm going to be using for the video. Instead, what I'm going to be using is one that I've got sitting over here next to me. And let's take a look at that. Okay, so what we have here is an Evo M51 board, but it's mounted on what we call our Evo tray. So I flip that over, you can see that. This is an Evo tray board. It's just basically a breakout board for Evo M51, because if you look around the edges of Evo, you can see that we've got these castellated vias. And we'll try to zoom in on that on the camera when we get a chance. It's one of the unique things about this board is it allows you to solder it down directly as a module, and you don't have to use the vias. Now, there are what we call interstitial castellated vias. So in between each one of those vias, there's a castellated via with each hole, but then there's some in between as well, which gives you a bunch of extra I/O that you can use. Now, that's really convenient when you're mounting it down inside of a project, but if you want to do some development with it, it's not as easy to use. So we have this Evo tray board that allows you to mount it on there, and so that's what we've got that I'm using for this video. Now, when you first get an Evo M51, I'm going to plug this in. When you first get it, it doesn't have CircuitPython running on it. If you get it, when you order it and it gets delivered to you, it's actually going to be running in Arduino Sketch, because it's also compatible, fully compatible with Arduino. And it will be running a sketch on there, and it'll just be blinking through rotating colors through the NeoPixel down on this end of the board, and then you'll get the just the blinking LED. Basically, that's the, hey, I'm alive, I'm working, and ready to go. So if you have an Evo M51, you plug it in brand new, this is what you're going to see. And this is the starting place where we're going to begin. I guess it makes sense to start at the beginning. And we're not going to do anything with Arduino in this video, because we've done other videos on that. And if you want to, you can go check out our YouTube channel. It's just youtube.com/aloriumtech. There's information on how to get started there. And we'll be continuing to add, of course, as we go along. Okay, well, the first resource I'd like to point you toward is CircuitPython.org. And this is really the place to go to get a lot of information about CircuitPython. Here you'll be able to see how many boards there are. We'll take a quick look at that in just a second, as well as this big getting started button here will take you to Adafruit's Learn guides about CircuitPython in general. And there are so many fantastic guides out there about how to use CircuitPython, how to contribute, how to build projects, all of that stuff. It's a tremendous resource. Don't have time for it in this video. We're going to focus on getting CircuitPython running on the Evo M51. And to do that, we need to go here to Downloads, because this is where we will download the bootloader that we'll put onto our code. We need the CircuitPython bootloader. And you'll see here when you come to the downloads page, this is where all of the companies and all the boards that are available that run CircuitPython are found. Well, there's probably boards that run it that aren't on here, but of the people who have submitted to be listed here, they're all here. And right now you can see there are 150 boards out there that support CircuitPython. It's really a very rapidly growing ecosystem. Very cool. Some very, very neat stuff that's being developed. Of course, a lot of hardware designed by Adafruit since they invented it, and they've been doing lots of board development, but not all. I mean, Arduino's there, SparkFun is there, Particle will run it, ST. I mean, just look here. There's all kinds of individual maker biz boards and all that. Tons of stuff, tons of options. Of course, what we want to find right now is our board. So if we search for Alorium, if I can type correctly, we can see Alorium Tech Evo M51 is listed there. And when you go there, this is the basics of the page. Now you'll get a page like this for all of these boards that are out there. And there's, along the left-hand side is a description of the piece of hardware, what it does, features, as well as any information where you can purchase it, things like that. There is a link here to the CircuitPython library bundle that you'll need for our board. We'll come back to that. You don't need it for the most basic functionality, but if you want to do some special things, or if you really want to use the full power of it, you will. We'll talk about why in a moment. Now, in order to get the bootloader file you need, or to get CircuitPython installed, we need to download this UF2 file. And if you go over here, you can see the most recent release of CircuitPython is 6.0.0 Alpha 3. So they're kind of getting ready to release 6.0.0. A lot of testing going on. There's a whole community involved with CircuitPython. Very cool thing. Again, don't have time for all of that right now. You can learn a lot more about that on the CircuitPython page. Active community developing this. What we want to do is click on this download UF2, and we'll grab that file. Now what I've done is I've created a special directory that I'm keeping that in, and I'll open that up. So I've got this CP day directory where we've got the UF2 file. So we can see we've got Adafruit CircuitPython. So these things are compiled specific to the hardware they're going to be running on, because there are different microcontrollers that can run it. There are different configurations of hardware. And so there's a whole process for submitting this to Adafruit's GitHub repository, and then it gets reflected on that page. So you want to make sure you grab the version for our board. And we can see that this is 6.0.0 Alpha 3. And the way we put this on is we actually have to put the Evo M51 into bootloader mode. Now the way that we do that is by double clicking the reset button. So I've got our Evo tray set up here. I'm going to reach over and do that. So when we double click it, it's going to put our board into what's called bootloader mode. And we should see it show up on the side over here in the sidebar as a drive. And so here it is. Let me open this up a little bit so you can see it shows up as Evo M51 boot. Now, this is one of the cool things about CircuitPython, is that it works a little bit differently than standard, what you might be used to with Arduino. And so honestly, I don't know all the details behind the UF2 bootloader and how that all works. And so I don't want to do the disservice of trying to explain it. But what I do know is that when you use CircuitPython, it will actually mount as a USB drive. The device will mount, and then the code you're editing, the Python code, actually lives on the device itself. And so you're editing the code in real time, and then it just runs it as you make changes, which is very interesting. It makes it very easy to just drag and drop code right onto that drive. But this first version, this first thing we need to do is to get CircuitPython running on it in general. So once we have it in boot mode here, as you can see, Evo M51 boot, we're going to grab this UF2 file. I'm just going to drag it right over, and as soon as I let go, it's going to load onto that drive, and then we'll see the drive disappear because it'll actually reboot itself. And the drive's rebooting, as you can see in the video. Now when it reboots and goes and resets itself, you'll see that it comes up, and now we see this CircuitPy drive hanging off here. And inside of CircuitPy, there are a couple of things. One is this code.py, which is the code that's running on the device right now, which I don't think should really have much in it. We'll take a look real quick here. We'll just open that up and see what's on there. I actually don't remember what is in there by default. I don't think there's really anything going on. We'll give VS Code a chance to warm up a little bit here. I should have had that running. Okay, so it's just a hello world program. That's all that's going on there. And then there's a lib directory. And then this boot out.txt just additionally provides some information about the design or the version of CircuitPython that's running. So we can see it's running the 6.0.0 Alpha 3. But this code.py file is the default file that runs, and so your programs that you run on CircuitPython are all going to be called code.py. I think it can also be main.py, but code.py is the standard that most people use. And so when we update our code, this is the file that we're going to be updating. Now, of course, we can write code, and this is how I usually do it. I write it somewhere else sitting on my hard drive, and then I drag it over. But we could actually edit this code right here as well. Now, one of the things you might be asking is, okay, well, I'm doing this print. Where's that showing up? Well, that's being sent out of the USB interface, so basically through the serial interface. But we need a mechanism to be able to look at that, and there are a couple ways you can do that. You can use serial programs that will talk serial device. There's a really nice editor called Mu, MU, that you can use for doing CircuitPython editing. We have to make Mu works with just specific hardware, and I need to add ours in so that it'll work with ours as well. But if you're using other like Adafruit devices, you can just connect to the serial monitor and Mu. It's really simple. What I tend to do is I tend to just use the utility screen, which is just built right into Linux, basically, or in my case, the Mac OS system. And so what I do is I like to look and see, okay, do I have a device sitting out there? And I can see that this USB modem, it looks like 14. I'm not wearing my glasses right now because I don't want reflections, but I need to put them on to see. So what we can do is I can run screen, and I can use this guy right here, and then give it a speed. Okay, so this is the output that's coming out of CircuitPython right now. And if I go over and actually touch that code, let me just change into this directory so we can actually go out, because it's mounted as a drive. I can actually go out on this drive, and we can see that here's my lib, my code, and my boot, just like we saw with the Finder window. Now, if I just touch this, whoops. Anytime CircuitPython detects a change to that code.py file, it'll rerun it. And so we see we got the hello world that came out right there. And actually, if I've got it also open in VS Code, so if I make a change in VS Code to that file, and we say, let's go and say, happy CircuitPython day, and I save that, it should make the change, and then it should rerun again. And so here we see it actually reran. So this is what's coming out of the serial monitor. So pretty simple to get things from 0 to up and running. Now, what we have done is we've created, so there's really a bunch of stuff you can do with this just like it is, because what we try to do, just like we've done with all of our hardware, is we want to make it really easy for users to take advantage of our FPGA-based hardware. So we want to try to keep things as similar as possible to the code you would write to just run it. So in the Arduino world, we create libraries to be able to handle all the FPGA things that might be happening, so that you can write your Arduino code almost exactly the same as you would for any other Arduino compatible device. It's just you need to do an include of one of our libraries, and then a lot of the function calls are exactly the same. It's very familiar. We're doing the same thing with CircuitPython as well. Let's go back to CircuitPython.org and look at our page here. And if you recall, when we scroll down in this description, there's a little blurb down here about our CircuitPython library bundle. And the reason we had to do this, we had to create a specific bundle, is keep in mind that with Evo M51, I'm just going to fire up this presentation real quick. The thing that's unique about what we have here is, again, we've got the Atmel SAMD51 sitting next to a Max 10, but all of the I/O is routed through the Max 10 FPGA. So everything going out to the through-hole vias, as well as all of the castellated vias, come through the FPGA. That's not exactly true. We have analog I/O that go directly to the SAMD, but with a couple of exceptions, all of the digital I/O run through Max 10. That means that we need to be able to handle the I/O. We need to be able to route data in and out and mux those inputs and outputs on the FPGAs, set them up as either inputs or outputs, depending on how you write your code. So there's actually some things going on in the FPGA that handle that. Now, again, we have other videos that talk about how we do that. And you could go and watch those as well on our YouTube channel, because what's really happening here is, if I just quickly jump through this, I won't go through all the builds, but basically if you look on the left, we've got our SAMD processor. That's got I/O hitting the FPGA. On the other side, these D, E, and G ports are the ports that go out to the outside world. And we need to be able to do some muxing and handle data flow from the SAMD to the outside world and back. And so we need a library that sort of abstracts all that away and makes it really easy for our users to be able to do that. Now, and to write code that's essentially the same as you'd write for another CircuitPython device. And that's what we have with our CircuitPython library. So if you click on this link, it will take you to the Alorium Tech CircuitPython Evo M51 library. And there are a couple of things that are in here. One, if we click on Alorium Tech, this contains all of the current library Python source files that you'll need. Without getting into too much detail about what is board I/O, bus I/O, digital, NeoPixel, things like that. These are all board, bus I/O, digital I/O, NeoPixel. These are all things that are standard with the CircuitPython release for just the regular release if you're just running on, like, say, a SAMD 51. But there are changes we had to make to handle that I/O muxing and the things you need to do to configure the FPGA fabric to work, so it's really simple for you to write your code. At the end of the day, what that means is that inside your CircuitPython code, if you'd see something like import board or import bus I/O in your CircuitPython, we'll see that we need to do from Alorium Tech import board, import bus I/O. And so what we want to do is we want to download the zip file, which you can do by clicking on this link. It'll take you to the download page, or you can also do it here as well. And I already have this downloaded, of course. And so we can go take a look at where I have that. Let me move this out of the way. And that's where I was here. So we'll go back to this. And I have examples and Alorium Tech. Now what we want to do, if you remember, we have in the actual, let me grab my Finder window. I probably minimized it. Oh, there it is. If you remember, out on the CircuitPython drive, there's this lib directory, and this is where you'll put all of the libraries that you need to run code. And there are tons of them. Not for us, we haven't made tons of them, but there are tons of libraries that Adafruit has developed, that other contributors have developed, that allow you to attach all kinds of peripherals and accessories and NeoPixels and LEDs and all kinds of sensors, everything. Tons of stuff out there, tons of work being done by Adafruit, by other people, to make CircuitPython really functional and be able to make it very powerful. And in fact, if you go to the CircuitPython.org page, there is a link specifically to go and find all of the libraries. So if you click that, you can get a bunch of libraries. And usually with any kind of example project, people are going to highlight what libraries you need. And it's fairly easy to go and find what you need. And in this lib directory is where you'll drop that stuff. In our case, we actually want to put the entirety of the Alorium folder into this lib directory. Okay, so I'm just going to do that by opening a new Finder window here. And I can grab this Alorium Tech folder, and I'll just copy it into the lib. Come on. And then it'll just copy everything right over there. And what'll happen, and are we watching this? So we should see, we kind of missed it because it happened quickly, but it again reloaded and restarted and reran that happy CircuitPython day here. Because again, anytime it detects a change in its file system, it'll rerun the code.py program. And now we've got that Alorium Tech folder sitting out there. So let's try an example. One of the things that we have here is an examples directory. And we could do something simple like, let's change the NeoPixel to blue. So we've got this NeoBlue file. In fact, why don't we look at that? And we go down into examples here. Oh, my desktop's getting a little cluttery. We'll move that out of the way for y'all so you don't have to look at all that clutter. Okay, now if we look at this NeoBlue, we'll open that up in VS Code. This is just a very simple example, but here's a good case of how we're using those library files. So you can see at the very top, We see from Alorium Tech import board, digital IO, and NeoPixel. Now, all of these are libraries that tell CircuitPython things about the hardware, how to communicate with it, and define things in terms of the board features, what the IOs look like, that kind of thing. And all this is going to do is it's going to set the NeoPixel blue, and that's all it does. Just a really simple test. Let's give that a try, and let's try to keep this open as well. Actually, what I'll do is I'll move this over here. This is kind of how I like to do my workflow when I'm working on things. So if you see in my term window here, I'll do a copy, NeoBlue, and I'm going to copy that out to volumes, CircuitPython, and I'm just going to rewrite over the top of code.py. And I got an error. What happened? Well, I don't know. Let's go have a look. So we get down here. I have NeoPixel. Oh, okay. You know what this error is? So this is actually good. I'm going to leave this in the video. Because I put a fresh install of NeoPixel or of CircuitPython, I still need the default Adafruit libraries in there, and I don't currently have that. And so I want to go and grab that. What we'll do is we'll go back here. We'll go to libraries, and we can grab what we're going to want is the version 6 bundle. So I'm going to download that. And I will open a Finder window. You get to watch me in real time make this all work for you guys. This is pretty cool. This is going to turn out to be a long video anyway, but that's okay. It's a good education. Let me get this ready. I'll go to downloads, unzip that file, then we can go into this directory, and I'll show you how we can do this. Okay. All right, so now we're in the CircuitPython bundle 6 file, and if we click down here into lib, what we're going to need is the NeoPixel, which is down here, and this .mpy is basically a compiled version of it. Now I want to drag this into the library folder, if this would cooperate. Okay. And let's see. All right, well, that took longer than I was expecting. I kind of left that dramatic pause in there when I added the new NeoPixel library because I was expecting that to work and it didn't. And you could see that I had this error that popped up and I wasn't expecting that. Well, it turns out there was a brand new release recently. I guess I'd need to look at when it came out of the most recent build of CircuitPython, which is what I downloaded from the downloads page. So if you remember, if we go back and look here, what I did, it's been like an hour since I tried doing that. I added that NeoPixel library and was expecting it to work, and I had to figure out what was going on because something else broke. Well, here's what it was, and I didn't want to drag everybody through all that in video. But here you can see that the latest unstable release is 6.0.0 Alpha 3, and that's just the one that I downloaded earlier in the video. Well, as it turns out, there's a change in Alpha 3 that breaks our I2C calls. Remember when we talked about how we've got this interface between the SAMD and the FPGA? Well, the way we manage that, the way that we actually configured the FPGA is across the special I2C bus between the SAMD and the FPGA that sets the inputs, sets the outputs, and handles all of that. So there's a change. In fact, if you go and look at the releases, and this is how we found it, I'll walk you through this part because it is kind of interesting. From here, you can go and you can look at GitHub and look at all the release information. So this is the Adafruit GitHub release information page, and here's the Alpha 3. Actually, we scroll down here to breaking changes since 5.x. So 5.3.1 is the last stable release, and I've been working with the 6.0 releases without any issues. However, there's this little bullet right here. the stop keyword argument has been removed from the I2C write to command, which is exactly what we use in our library. And so if you look at the error that we had, that's what it was complaining about. And what we ended up doing is going back into our library that's on this board and changed it and took that out. So now if we go and we were to read that code or look at that code, we've actually got that commented out. I don't have that code open right now, but then it works. And so now I'm going to go, I will touch, oops, let me go here, and I'll do a touch, volumes, CircuitPy, code, and hopefully it'll dump out here. Yep, so it's saying NeoPixel blue, and you see the blue NeoPixel. Now, one of the things I realized looking at this is that blue color is kind of hard to see in the video because it oversaturates so well. But just to show you that it's working, if we just do a quick edit of this code, and let's just say we, instead of doing blue, we want to change the color to red instead. And we'll change this to a blue. Now it's still going to say, oh heck, we'll go up here and we'll say NeoPixel red. Okay, now remember, I'm actually editing this code.py file right on the drive. When I hit write, we should see the NeoPixel turn red, and we also should see it show up over here. So this is my screen I'm using, reading it, and we're seeing it there too. So that's a good thing that we're seeing that change. So we have it up and working with a very basic functionality, and that is all good. Now what I want to show you is a simple file or simple program that we call, am I in the examples directory? Let me go back in the examples directory. I'm going to don my specs again because I can't see very well without them. Okay, now if we go and let's take a look at this one that we call get Evo info. And what this will do is this goes out and it queries some registers that are sitting out there in the FPGA to tell us some information about the code. Now I can see right away from looking at this two things. One is that this is an older file. Looks like we need to update this in our library. This is actually a great example. So this stop command is what was causing problems in the I2C write to. And in this particular version of this program, it looks like I still haven't updated this to have the new bus IO stuff so we can just access the I2C directly. So that's got to be updated on GitHub for us because those library changes, we just did an update a couple of days ago that with our own information there, so we don't have to have this in the sketch itself, or not in the sketch, but in the program. So I'm not sure if this is going to work. Let's give it a try. And let's do copy, get Evo info, CircuitPy. Okay, so we'll copy that over there. And we'll see what kind of information. Yeah, so this is a good example of the error that we just ran into. So we can see this extra keyword argument is given. If we go down here to this, we can take this out. And where else? Did we have another I2C command, or is that it? Here we go, write to. We'll take that one out as well. And we'll see if this makes a difference. Okay, so now it ran, and we can see we've got get Evo info, product is Evo M51, board revision 2020-02, the FPGA is the 10M25, FPGA release 01, SVN 237. So this is all correct. This is dumping out the information about the Evo board itself. Now we have a bunch of other things we can do with this as well, and one of my favorite things to do is to do IoT-like things, which is to get our board connected onto a Wi-Fi network and be able to do some things with that, because it will allow us, one, to be able to control the device if we wanted to control through a dashboard, or be able to harvest data through some kind of a sensor or something like that, and then be able to send it back to a dashboard or whatever. As a simple example, I have what we refer to here as the Evo box. I'm going to change out this board, so I'm going to remove this. And what I'm going to do instead is I'm going to plug in this box here, and you'll get a better view of what's going on here. Okay. Now, All right, well, this is our Evo box, and what this is our Evo M51 board sitting next to an Adafruit Airlift Featherwing. So this has got a Wi-Fi module on it, and this will allow me to be able to connect to the internet on that and be able to talk to some dashboards and things like that, start doing some IoT-ish kinds of things. Now, we can connect with a couple of different dashboards and different IoT platforms, but the one I'm going to focus on in this particular video is the Adafruit IO, and because it is CircuitPython Day, and so I want to support Adafruit and promote their stuff because they have been really awesome at supporting us as we've been getting our CircuitPython running on this board. Now, here's the thing I'm not really sure. So this is running Alpha 3. This should be okay when I copy the example over there because I haven't changed the evo.py. So the I2C writes should be okay. Well, let's give this a try. If we look here, we can see Evo. So I've got this file called evo_adaio.py. This was taken from a Learn guide that Adafruit has out there on how to connect to Adafruit IO using CircuitPython. I had to modify it a little bit. Okay, so let's take a look at this Evo Ada.io source file. And if we do that, you can see the changes that we had to make to it where we're incorporating our libraries instead of the stuff that we're using from Adafruit. Here's the section. You can see that from Alorium Tech, import board digital IO, bus IO. These are the things you've seen before. And in the other simple example, we didn't bring in bus IO the way we're doing here. I guess we're kind of duplicating that now that I see it, but that's okay. And then there's a whole bunch of other libraries that are required from the Adafruit library stuff that we need in order to pull this off. I showed you that link earlier from the CircuitPython site. Very easy to go out and find. And then all of the details about connecting to the Wi-Fi is kept in a secrets file. So there's a secrets.py in this directory. And basically it does a connection, and all of this is a really simple program that just generates a random value between 0 and 50, pushes it up to Adafruit IO, and then waits 10 seconds and then does that again. Now, hopefully this should all work just fine. So we do this, and this is the Evo box is the name of this. You can actually change the drive name. It defaults to CircuitPy when you mount your CircuitPython drive, but it doesn't have to be that way. So if we copy that over, we should see it update. Now, that red LED tells me that it has changed because I know that's a status LED for this program. And when it's trying to get connected to the internet, it'll be red, then it'll turn blue, and then it will connect and start sending data. Now let's go here to this Xterm. We'll try this first, and we'll see if we can reconnect to it across the USB. We do screen. And what we should start to see is when it sends some data, it will connect. In fact, why don't I do this? I'll just start over so that we can see what the output of the file looks like or what it's doing. So again, it's making the connection. So it's using the Adafruit libraries to get connected to Adafruit IO. And then we should start. So here it is, sending 41 to random feed. So this is, it looks like I have some output here that is superfluous, but I'm not going to worry about changing that. And now if I go to Adafruit IO, I have an account there, and you can see that I've got this graph, and it's actually sending data across. And so here's our number 41. That's the one that just got sent. In fact, we move this so that you can see what's coming out here. Then 50. Hopefully this is 50. Yep. And so every 10 seconds, it'll start sending this data and start shipping across here. Now, you certainly do not need an FPGA to generate random numbers and send them to an IoT dashboard. That's absurd. But the idea here is that one of the areas that you might want to use, and where our customers are indeed using our hardware, is for doing much more aggressive or much higher performance processing of sensor data, some kind of sensor fusion applications where high fidelity analog to digital reads are being done, brought into the FPGA where there's some DSP algorithms happening, and there's a lot of those happening in parallel, and then that data is what's getting pitched out of the board and either up to an IoT dashboard or as part of a host system in a larger compute environment. And so that's where using the FPGA starts to make sense. So this is really what I wanted to show in this video. And it's kind of interesting because we took a little bit of a detour in terms of discovering a couple of things that didn't work like I was expecting it to, but that's okay. CircuitPython is ever evolving, and some of the changes that get made, actually the community, the lead developers that are working on it are really great about communicating things that change, what's going to happen. And there's a weekly meeting every single week that you can be part of. Anybody's welcome to attend if you're interested in learning more about it and developing, and it's led by some of the key contributors from Adafruit, but everybody's welcome to be part of the community. There's a Discord channel that you can join if you want to learn more, get help, whatever. I'll put links to all of those things in the description for this video. For now, I just wanted you to see that it actually is really very easy to get CircuitPython running on your Evo M51 board if you want to learn how to do work with CircuitPython. It's a great environment. It's one of my favorite languages to use for doing microcontroller development at this point. I just love it. And I wanted to bring that to you today, September 9th, 2020, CircuitPython Day. If you have any questions, please shoot us an email at support@aloriumtech.com. You can learn more about Evo M51 at aloriumtech.com/evo. And you can also go and check out some of the documentation, check out our quick start guide where we do have information about how to use CircuitPython with Evo M51, as well as using it with Arduino and a bunch of other information out there. But the CircuitPython section is being updated all the time as we speak. As I mentioned, we just upgraded some of our libraries. We'll do another update today based on just some of the stuff I found going through this tutorial and making this video. So continue to check back. Encourage you to get involved with the CircuitPython community, get involved as one of our customers, buy one of our boards, check things out. We would love to hear what you are building, what you're doing with your FPGA-based hardware. So thanks for watching this video. Have a great CircuitPython Day 2020. Take care. We'll see you soon.